So environmental chemistry, this is mainly related with CBSE and NEET examinations. So after this lesson, the next part we will discuss the questions of this. So stay tuned with my channel, and I'll be able to provide a lot of information which will help you in the NEET exam. So what do you mean by environmental chemistry or the environmental studies? We know it is the interrelations of biological, social, economical, uh, social, economical, studies that relates to our surroundings, and this is called as environmental studies. So how we can define this environmental uh, uh, chemistry? This environmental chemistry, it deals with the study of the origin, transport, and this origin, transport, this reaction, effects and fates of chemical species in the environment. So what is environmental pollution then? So the undesirable changes, it is the undesirable changes that have harmful effects on plants, animals and human beings in our surroundings is called the environmental pollutants or environmental pollution. And the pollutants which brings this environmental pollution, these are the particles. So the pollutants can be defined as the substances which cause pollution and is harmful for the environment. It is harmful for the environment. So pollutants can be biodegradable or non-biodegradable. Okay. So the substances, it can be biodegradable, uh, biodegradable and non-biodegradable. So pollutants can be biodegradable and non-biodegradable. Okay. So those substances which are degraded rapidly by natural process or artificial methods degrade naturally um, rapidly, they are called the biodegradable pollutants. Okay. Those substances which degrade at a very slow rate by natural biological process. Biodegradable is both naturally or artificial also. And non-biodegradable degrade at a very slow rate. It may be natural biological process. It is a natural biological process and its process is very slow. For example, DDT, arsenic, salts of heavy metals, radioactive materials and plastics are non-biodegradable. You can note down the examples such as DDT, arsenic, salts of heavy metals, radioactive materials, plastics. These are all non-biodegradable material. Now next we come to the atmospheric pollution. The atmosphere that surrounds the earth it's not the same thickness at all places. It is greater at the equator and the distance is small at the poles. Uh, at the equator it is nearly about 15 kilometers, and in the poles it is about 8 kilometers. And the addition of particulate matter, gases and other ingredients into air, which will have adverse effect on vegetations, animals, human beings, human assets and resources. So lowest layer of atmosphere is the troposphere, which have the dust, water vapor and the clouds. So if this is the earth, so the lowest level is the troposphere. It has dust, water, vapors and clouds. And its height is about 10 km from the sea level, and above the troposphere lies the stratosphere. Now this atmospheric pollution includes both this troposphere and the stratosphere. Both this troposphere and the stratosphere. It includes both the troposphere and the stratosphere. So we call it tropospheric or stratospheric pollution. So this tropospheric pollution is due to the pollutant. Now, which are two types? It may be the primary pollutant or the secondary pollutant. So the primary pollutants we may call those pollutants that are persisting in the environment in the form it is produced. Example of the primary pollutants are the carbon monoxide, and the secondary pollutants are the pollen grains, natural fog, volcanic eruptions, bacteria, dust, smoke, mist, fumes, gases, vapors. These are all the secondary pollutants. Now, these secondary pollutants are formed from the primary pollutants by reaction or by change. So you may note down the examples of the primary pollutants and the secondary pollutants. So gaseous air pollutions, that are main cause are responsible, the oxides which are responsible for the pollutions of the gaseous air pollutants or the particulate pollutants. The oxides of sulfur, nitrogen, carbon, hydrogen, sulfide, hydrocarbon, ozone and other oxidants. These are called gaseous air pollutants. And among the particulate pollutants, the dust, mist, smoke, fog, smog, etc. Now, oxides of sulfur is SO2 or SO3, and this evolved. This 67% is 67% available of this pollutants. Availability of these pollutants is from volcanic eruption, and 33% by metallurgy of sulfide ores. 67% from volcanic eruption and 33% by ores of sulfide, from ores of sulfide or sulfur containing fuels. So it is low concentration and it causes the respiratory diseases, which are the respiratory diseases like asthma, bronchitis, emphysema in human beings. Asthma, bronchitis and emphysema in human beings. It also causes irritation to the eyes also, resulting in tears and the redness. And even in plants also, high concentration of sulfur dioxide may lead to the stiffness of the flower buds, which eventually falls off from the flowers. Sorry. Now we know that uncatalyzed oxidation of sulfur dioxide is very slow. Okay, the presence of particulate matter in the pollutant here catalyzes the oxidation of sulfur dioxide to sulfur trioxide. So let us see the reaction, how SO2 is converted into SO3. Now SO2 reacts with the oxygen of the air to form the twice SO3. It can also take place by O3 and H2O2, that is by ozone and by H2O2, hydrogen peroxide. So SO2 reacts with the ozone to give SO3 and oxygen, and SO2 reacts with H2O2 to give you H2SO4, sulfuric acid. So SO3 is very harmful than SO2. Since SO3 is very harmful, it is very harmful, it is very harmful, it is very harmful than SO2. Okay, SO2, because it combines, we have already seen that it combines with water to form sulfuric acid, which causes acid rain and causing yellowing of the Taj Mahal and many other monuments, such marble monuments which are made up of carbonates of calcium. Now let us come to the next part, that is oxides of the nitrogen. So these oxides of nitrogen are dinitrogen and the dioxygen. This dinitrogen means the two atoms of nitrogen are present in a compound of nitrogen, or two atoms of oxygen are present in a compound of oxygen. So they are mainly composed of combustion of fuels, fossil fuels, especially at high temperature in automobile engines, mainly NO and nitrous oxide and NO2, nitrogen dioxide. So now at high altitudes, when lightning strikes, they combine to form oxides of nitrogen. So NO2 is oxidized to nitrate ion, and NO3 minus, which is washed into the soil, it serves as a fertilizer. So NO2 is oxidized to nitrate ion and NO3, which is washed into the soil, and it takes place when lightning strikes. So thus it serves as a fertilizer. In automobile engine at high temperature, when fossil fuel is burnt, dinitrogen and this dioxygen combine to yield significant quantities of nitrous oxide, this nitrous oxide and nitrogen dioxide as given below. So let us see how this reaction takes place. Now this reaction is already given, so I am not writing it again. It takes place at 1483 Kelvin to form NO, and this NO in turn reacts with oxygen to form the nitrogen dioxide, and rate of production of NO2 is faster when nitric oxide reacts with ozone in the stratosphere. Okay. Now what are the effects of this? What are the effects? Now its effects are, these are the effects. They produce reddish brown haze or brown air of NO2, which is more dangerous than NO. Brown air of NO2 is more dangerous than NO. Let me write here, brown air of NO2 is more dangerous than NO, and their oxides causes several diseases. pulmonary edema, dilation of arteries, pulmonary edema, OEDEMA, dilation of arteries, eye irritation, heart problems, liver injury, it may be kidney also. Okay, and last of all, it causes acid rains, which harms the fertilizer, which harms the crops, harms crops and other buildings. Okay. So next is the hydrocarbon. They are composed of hydrogen and carbon. They are produced naturally. Example, the Mars gas. Example, Mars gas, when it is produced naturally. Example is Mars gas, as well as due to incomplete combustion also. Incomplete combustion in automobiles, this can also lead to the production of hydrocarbon. And these are very carcinogenic. That means it can cause cancer and causes irritation of mucous membrane eyes. They causes aging, breakdown of tissues, and shedding of leaves and the flowers. So Mars gas example. Next is the oxides of carbon. So carbon monoxide is one of the most serious air pollutant, and it is the colorless and odorless gas. It is produced by incomplete combustions of the fuels. It is produced by incomplete combustion of the fuels. Naturally, it is produced by oceans or by decaying of organic matter by bacteria, and it is very poisonous because it combines with the hemoglobin of the blood to form carboxyhemoglobin, and it is 300 times more stable. What it does, it reduces the oxygen carrying capacity of the blood and results in giddiness, headache, decreased vision, cardiovascular malfunction, and asphyxia. Cigarette smoke also contains a lot of carbon monoxide, which induces the premature birth in deformed babies, and especially for women, and spontaneous abortion in pregnant women. So it causes a great harm in pregnant women also. Now we can go to carbon dioxide, which is released in the atmosphere mainly by volcanic eruption and by respirations, by volcanic eruptions also, CO, by volcanic eruption, automobile exhaust, factories, respiration, etc. Now, increased level of this carbon dioxide is controlled by green plants during photosynthesis. Plants take in photosynthesis, and carbon dioxide is a greenhouse gas, and it is also responsible for global warming. It causes headache, nausea, and asphyxiation. It causes headache, nausea, and asphyxiation. Now we can identify air pollution that during air pollution, if you go to a busy street in suppose in Calcutta or any metropolitan city, uh, you can feel some irritation in the eyes. In daily roads also, you actually taste in the mouth, unusual odor, and effects can be observed. Its growth, both the growth of plants and in animals also. So now we'll go to greenhouse effect, global warming and greenhouse effect. So this effect, global warming, was first discovered by Fourier. It was first discovered by Fourier. It was first discovered by Fourier, and the term was coined by Arrhenius. It is coined by Arrhenius. Now, 75% of the solar radiation is absorbed by the Earth's surface, and the remaining is reflected back. Now, some of these are absorbed by greenhouse gases, which increases the temperature of atmosphere, and this effect is called the greenhouse effect. Now, there are various greenhouse gases. The greenhouse gases are there: CO2, methane, CFCs, N2O. These are all the greenhouse gases. There is a chlorofluorocarbon, is called chlorofluorocarbon, CFC. Now, ozone is also a greenhouse gas. So now what are the effects of this greenhouse? Now, it increases the global temperature and it results in extreme climatic conditions. Global warming push tropics into temperate areas. The tropical region becomes temperate areas, and temperate areas towards the pole called shifting of climatic zone. Thus, the shifting of climatic zone takes place due to this greenhouse effect. And some diseases, some infectious diseases spreads very rapidly, and there are dengue, malaria, yellow fever, sleeping sickness. These types of diseases spread very rapidly. So if the concentration of the carbon dioxide crosses the limit of 0.03%, then the natural greenhouse balance gets disturbed. So natural greenhouse balance gets disturbed if the concentration of the carbon dioxide increases the proportion of 0.03%. So, and carbon dioxide is thus a major contributor to global warming. Okay. Now this greenhouse gases, so the methane is produced from naturally when vegetation is burnt or digested or rotted in the absence of oxygen. So large amounts of methane are released in paddy fields also, coal mines and rotting garbage dumps, and by fossil fuels. Now chlorofluorocarbon, or the CFCs, these are man-made industrial chemicals and air conditioning, used in air conditioning, and it damages the ozone layer. Now, in recent years, this level have increased considerably due to the increased use of the fossil fuels. Now, let us come to this acid rain. Now, normal rainwater has a pH of 5.6. It is a pH of 5.6, and due to the presence of this H plus ion in it, formed by the reactions of rainwater with carbon dioxide present in the atmosphere. So rainwater plus carbon dioxide in the atmosphere. This is these reactions gives you the H2CO3. It is in aqueous form, and this H2CO3 in turn reacts with H plus ion to form HCO3 minus. Now, in this way, when the pH drops below 5.6, it is called acid rain. So we can write the reaction in this way. H2O plus CO2, this is a reversible reaction, H2CO3, and sulfur dioxide. This is step number 1 reaction. Number 2 reaction is sulfur dioxide reacts with the oxygen to form H2SO4, and NO reacts with oxygen and water, means water vapor in the atmosphere, to give nitric acid. When these acids come to the earth's surface along with rain, all these acids comes to the earth's surface along with rain. These come to the surface of earth. We call it acid rain. Okay. Now we know a very good example of this effect is that Taj Mahal is largely affected due to this acid rain. In the Taj Mahal, what happens? High level of sulfur and nitrogen oxides caused by combustion of kerosene, poor quality of coal and firewood causes acid rains. Sulfur, nitrogen oxides, and a high level of this. Its level is very high. And this is caused by combustion of kerosene, poor quality coal and firewood. And what is its effect? Now this brings the acid rain. we have seen earlier that what are the acids: H2CO3, H2SO4 and HNO3. So these acids, when fall on this marble, that is COCO3 of the Taj Mahal, H2SO4 or any other monument, it reacts with it to forms calcium sulfate, H2O, H2O and carbon dioxide. So the pitting and erosions of this marble occurs, and there's some black spots has also been observed. So the government has tried and initiated several steps so that this can be preserved as it is. And the natural nearby areas, the use of these fuels have been restricted. In instance, natural gas and LPG have been used, and people are also encouraged to use LPG fuel or the green fuel. Nowadays, electric vehicles are also can also be seen in these areas plying over there instead of this diesel fuels. Vehicles are also encouraged to use low sulfur content diesels. So next is the particulate pollutants. The particulate pollutants, these are the minute solid particles of the liquid droplets present in the air, and it may be viable and non-viable. The viable are the living organisms like the bacteria, fungi, algae, molds, etc. And there are non-viable products also, such as the dust, mist, smoke, fumes. These are all non-viable particulates. Now, dust are the particles from sandblasting. Dust are obtained from particles from by sandblasting of woodworks, pulverizing coal, ash of factories, dust storms, and the size is over 1 micrometer in diameter. And smoke is obtained from, that various sources of smoke: combustion of fuels, cigarettes, dry leaves, garbage consist of solids or mixtures of solids. People used to burning the dried leaves. And mist is obtained from the condensation of vapors. I've already told you. Now fumes are obtained from condensation of vapors, also from boiling, distillation and sublimation, etc. Now mist can be from sulfuric acid, herbicide, insecticide, etc. While fumes can be from organic solvents, metallic oxide, etc. So that's the difference between the mist and the fumes. That I repeat once again, that mist can be from sulfuric acid, herbicide and insecticide, etc., while fumes can be from organic solvents and metallic oxide, etc. Now particulates which have the size less than 5 micron enters in the lungs, while bigger than 5 microns lodge in nasal passage, and it leads pollutions from leaded petrol that interferes development and maturation of the RBC also. So it causes a loss of destruction in human being. Now the word smog is derived from smog plus fog gives you the smoke. It is smoke plus fog gives you smog. They may be opaque or dark. Now we classify this smog into two types as classical smog or photochemical smog. The classical smog occurs in humid climate. The classical smog and the photochemical smog, it occurs in the cold humid climate, and it is a mixture of smog, fog and sulfur dioxide. So smog we can divide into two types as the classical and the photochemical. So classical is a mixture of, it is a mixture of smoke, fog and SO2. And photochemical smog, it is also called oxidizing smog, as it contains O3. It contains O3. Its sunlight falls on unsaturated hydrocarbon plus nitrogen oxides. When sunlight falls on hydrocarbon and nitrogen oxides produced by, we know these are produced by automobiles and factories, then photochemical smog is produced. Is result in photochemical smog. That means photo means light and this is chemical. And is at high concentration of oxidizing agents, I told you, and so it is also called as photochemical smog. You can call it also as Los Angeles smog. Okay. It contains, I've told you, O3 and pan. Now, what is this pan? This pan is peroxyacetyl nitrate. Peroxyacetyl nitrate. So it is an important component of smog, and pan is a gas at normal temperatures and pressures. Its chemical formula is C2H3O5N. C2H3O5N. It's chemical formula of the pan. So we can see that this molecule is composed of the carbon, hydrogen, oxygen and nitrogen atoms. Now, how photochemical smog is formed? So when burning fossil fuels, these hydrocarbons and nitric oxides are produced. NO converts into NO2. NO converts into NO2 in presence of sunlight. It gives NO and free oxygen. Now this free oxygen forms O3 with O2, and this O3 gives NO2 on reaction with NO. Now let us see with the reaction how this takes place. So NO reacts with the oxygen to gives twice NO2. This oxygen of the air, and its NO2, this NO2 in turn forms, and this O plus oxygen of the atmosphere reacts to form the O3. And these NO and O3 and these NO and O3 reacts to form NO2 plus O2. Now strong oxidizing agent, this is a strong oxidizing agent, NO2 and O3 reacts with unburnt hydrocarbon to form formaldehyde, acrotine and peroxyl acetyl nitrate. I have already told you there is a full form of PAN, 3CH4 plus 2O3, 3CH2 double bond 2. Something wrong in my pen. So this PAN causes the effects of PAN reduced visibility, irritation of eyes, and respiratory tract, irritation of respiratory tract or infection in the respiratory tract also. Now this photochemical smog is brown in color. Photochemical smog is brown due to the presence of brown Na2. Now, various methods to control photochemical smog. Now we can control it by controlling primary precursors of photochemical smog. By controlling primary precursors. Example, NO2, hydrocarbon, etc. By controlling secondary precursors, example, ozone and PAN, etc. By plants which metabolize oxides. Example, pinus, juniperus, quercus, pyrus and vitis. By using catalytic converter which prevents release of nitrogen oxide and hydrocarbon. which prevents release of nitrogen oxide and hydrocarbon. Now, stratospheric pollution. Sorry. Now, ozone formation, stratospheric pollution. We have discussed that stratosphere layer is from about 18 to 50 kilometers above the sea level, and the ozone formation and its breakdown, how it takes place. Now, molecular oxygen, this splits into, in presence of ultraviolet light, into O and O. This free oxygen atom by ultraviolet radiations. Now it combines with the molecular ozone. And this combines with the molecular ozone, molecular oxygen, to form the ozone. Okay. Both are in gas form. Now, we know ozone is thermodynamically unstable. Is thermodynamically unstable. Hence, exists dynamic equilibrium between its decomposition and formation, and hence it and hence there exists dynamic equilibrium between its decomposition and formation. Okay. Now, ultraviolet radiation dissociates chlorofluorocarbon to give chlorine-free radical. Ultraviolet radiation, it dissociates CF2Cl2 to form to give chlorine-free radical, which combines with ozone to form chlorine monoxide radical. Let us see the reaction. CF2Cl2 in presence of sorry. So this ultraviolet radiation dissociates chlorofluorocarbon to give the chlorine-free radical CF2Cl, which combines with the ozone. This again combines with the ozone. This combines with the ozone to form uh, chlorine monoxide radical. This is the chlorine monoxide radical, which combines with the free oxygen. It combines with the free oxygen. It combines with the free oxygen here to form this free oxygen to form chlorine free radical. This is a chlorine free radical and the oxygen. And this chlorine free radical, this is responsible for depletion of the ozone layer. So now we will study the ozone hole. So in 1980s, atmospheric scientists working in Antarctica reported about depletion of ozone layer, commonly known as the ozone hole over the South Pole. So at that time, people were stunned by hearing such a decision or such a declaration from the scientist. It is found that a unique set of conditions was responsible for that ozone hole. So it is found over restricted areas over Antarctica. So stratospheric clouds are formed over Antarctica. On its surface, chlorine nitrate. So if this is the chlorine nitrate gets hydrolyzed to form hypochlorous acid. Chlorine nitrate ClONO2. This is chlorine nitrate. It gets hydrolyzed to form. Hypochlorous acid. That is HOCl. It is called hypochlorous acids plus nitric acid. Which reacts with the hydrogen chloride to give molecular chlorine. So this again reacts with this reaction now we'll study it later. Now let us see the effect of this ClONO2, that is the hypochlorous acid with hypochlorous acid is formed, and now what happens is this chlorine nitrate ClONO2 it reacts with HCl, hydrochloric acid, to form Cl2 plus HNO3. Now this ClON2 and HCl, and this HCl, they are formed in summer seasons only. They are formed in summer seasons. These are formed in summer. by the reaction of nitrogen dioxide and chlorine monoxide. The reaction takes place in this way: ClO, NO2, ClO, NO2. Sorry, ClO, NO2. How it is formed? So I repeat once again, this ClONO2 and HCl are formed in summer season by the reaction of nitrogen dioxide and chlorine monoxide radical and reaction of methane and chlorine radical respectively. So what happens is this: this Cl, chlorine free radical, reacts with methane to give CH3 plus HCl. Now when in spring season, what happens? The sunlight breaks HOCl and Cl2. In spring, the sunlight breaks HOCl and both Cl2. Now chlorine free radical is obtained. So these chlorine free radicals, this depletes the ozone layer. This depletes the ozone layer. Depletes the O3 layer. So you can see the reactions over here. Now effects of depletion of ozone layer. What are the effects? Effects of depletion of ozone 3. So ozone layer is depleted. How it affects us? So what is to us if it is depleted? Of course, it causes a great harm to human life. So ozone is commonly called O3 is commonly called weed in troposphere. Now bad O3 formed in the troposphere it harms plants and animals. While good ozone formed in the stratosphere, which acts as a shield. Good O3 formed in stratosphere now it acts as a shield. So it protects the ultraviolet rays from entering into the Earth's atmosphere, this good O3, and it helps us to protect us from skin cancer. And also it increases transpiration rate, and hence decreases soil moisture. And another point is that it damages plant and fibers. This bad OH damages plant and fibers, this ozone, and causing them to fade faster. So next we will study. So now is causes of water pollution. So now we know any unwanted change which deteriorate the quality of water and make it unfit for drinking is called water pollution. Now, how does it originate? It originates from the activities or foul activities, rather we can tell, from human being, which is not wanted. And so pollution source of these water pollutions are two types. One may be point source and one may be non-point source. So point source, they involve the discharge from unidentifiable points, example discharge of waste water from factories, which sometimes cannot be identified from where the polluted water is coming, in the river or in the lakes or in the oceans. And another is the non-point source, which involve discharge from the point source that discharge from identifiable source from which you can point easily. These factories, these are releasing waste. Industries, big industries, they're releasing the waste into the rivers, the lakes, and in the oceans. And some points which are not identifiable, that includes the discharge from land, runoff, atmospheric washout, etc. And these are called the non-point sources. So I repeat once again that water pollutions can be from two types of sources. It may be from sources of water pollution. It may be from two types of sources. One is the point source and one is the non-point source. So point source can be pointed, that means it can be identifiable, whereas non-point source cannot be identifiable. So it is identifiable this example, discharge of waste from factories and industries, and this non-identifiable from land runoff, example land runoff, atmospheric washout, etc. Now there are several causes of water pollution. So these are caused by organic matters such as the okay, let's just first discuss about the pathogens. These are disease causing agents called the pathogens and they are the most serious water pollutant. Is the most serious water pollutants. They are disease causing agents. It includes bacteria and other organisms, and it enters the water from domestic sewage. There's viruses, bacteria, protozoa, helminthes, algae, etc. Human excreta contains the E. coli and Streptococcus faecalis bacteria which cause gastrointestinal diseases. Escherichia coli or Streptococcus faecalis which causes gastrointestinal diseases. A question may come from this. Now next is the organic waste such as the leaves, grass, trash, etc. as well as excessive phytoplankton growth in water causes water pollution. As this matter it causes water pollution. They pollute water as a consequence of runoff. The excessive phytoplankton growth in water. Now this water pollution as this matter is decomposed through microbial activity, and this microbial activity is known as putrescibility. It is known as putrescibility, and it requires oxygen. So I repeat once again. So there are some organic matter such as leaves, grass, trash, etc. as well as excessive phytoplankton growth in water. It causes water pollution as the matter is decomposed through microbial activity and it is known as putrescibility and it requires oxygen. Now degree of the impurity of water due to this organic matter is measured in terms of biochemical oxygen demand. It is called BOD or biochemical oxygen demand. Its degree is measured from this. For clean water, the BOD shall be less than 5 ppm. Clean water BOD is less than 5 parts per million, whereas in highly polluted water it is more than water it is more than 17 or ppm. Now BOD is the amount of oxygen required by bacteria to break down organic matter present in certain volume of a sample of water. So we can define BOD in this way. It is the amount of oxygen required. It is the amount of oxygen required to break down organic matter present in certain volume of a sample of water. Okay. Now the table is given. Some major water pollutants. There are microorganisms. These are the domestic sewage, organic waste. This is domestic sewage, animal excreta and waste, decaying animals and plants, and discharge from food processing factories. So plant nutrients. These are chemical fertilizers and this toxic heavy metals. This main source is the industries and the chemical factories, from industries and chemical factories, and the sediments are from erosion of soil by agriculture and strip mining, and pesticides is from chemical used for killing insects. We used to give these pesticides for killing insects, fungi and weeds in the fields. And Radioactive substances, the main source is the mining of uranium containing the minerals. And of course the heat, that is the water used for cooling in industries. Okay, so that is the microorganism, its source is domestic usage, and these the organic waste, and plant nutrients is the chemical fertilizers. So these are the pollutants, main pollutants, and these are the main sources. So now we come to chemical pollutants. Now there are two types. These chemical pollutants are two types. They are inorganic and organic. Now inorganic pollutants constitutes acids, salts, heavy metals such as cadmium, mercury, nickel, etc. And heavy metals can damage the central nervous system, liver, and kidney. So inorganic pollutants, its example acids, salts, heavy metals. These are cadmium, mercury, nickel, etc. So what does these heavy metals do? Now these heavy metals, they damage the central nervous system, damage the CNS, damage central nervous system, liver, kidney. So these organic pollutants, these constitute the pesticides. It constitutes the pesticides, petroleum pollutants, and PCBs and detergents. Detergents, fertilizers. Now PCB is known as polychlorinated, polychlorinated, polychlorinated biphenyls, BIPHENYLS, biphenyls. Biphenyls, polychlorinated biphenyls, PCB. So these are carcinogenic and phosphatic fertilizers, uh, these PCBs. This is carcinogenic. And phosphatic fertilizers, and fertilizers which are in phosphatic in nature, it increases the algae growth, it increases algae growth. Acidic water is harmful for aquatic life as well as for drinking. Now, the process in which this nutrient-enriched water bodies support a dense plant population and it results in depleting oxygen level and hence killing animal life. This result in loss of biodiversity is called eutrophications. Now, we know this the definition of eutrophication. It is the process in which uh, the nutrient enriched water bodies, means the water bodies which have high nutrient, they support a dense plant populations. The plants are very dense over there, and these kills animal life. Once the plants are dense, so the animals are deprived of oxygen, and they cannot come off as they wish, or they cannot get sufficient oxygen because plants consume this oxygen and results in sufficient loss of the biodiversity. This is a subsequent loss of biodiversity. This process is known as eutrophication. So this is very important. And now there are some international standards for drinking water that you have to remember. I will give you a chart, and in the chart you remember these things only. And now the chemicals its tolerable limits and its effects. Number one is nitrates. Its tolerable limit is 50 ppm, parts per million. It's 50 ppm, and it causes blue baby syndrome in excess. In excess, causes blue baby syndrome. Number two is fluoride. Its tolerable limit is 1 ppm. It excess is poisonous and harmful. In excess, poisonous and harmful for bones and teeth. Now next is the sulfates. Its tolerable limit is 500 ppm. In excess, of course, in excess, it causes laxative effect. Lead. Its tolerable limit is in excess, it causes damage to kidney, liver, and the brain. Kidney, liver, and the brain. Now, what are the measures to control the water pollution? You have to take certain measures. Number one is the treatment of sewage. First, this sewage is churned properly. First is it is churned properly by machines, and then passed through a tank, and then it is passed through a tank, and then it is passed through a tank. While heavier particles settle down, then flowing pure water is sterilized. What happens? The heavier particles settle down over here. This is the heavier particles. Settle down and pure water is obtained. Then this pure water is sterilized by chlorine. Then it is treated with alum. Alum and lime, etc. Thus drinking water is obtained. Now, treatment of industrial waste is the first step. Is now that is measurement of the sewage, treatment of the sewage, and now is the treatment of the industrial waste. First is pH is determined, then it is neutralized. Industrial waste. Treatment of industrial waste. First, what happens? Determination of pH. The neutralization with acid or alkali. Chemical treatment. For deposition of dissolved chemicals. Nowadays we use ion exchanges and photocatalysis. Now, Hippocrates was the first to recognize this problem of water pollution. Now, and DDT was the use of DDT was banned in 1985 in India for agricultural purpose. But still, now we have seen in some places. Now, soil pollution, which is an unfavorable alternation of the soil by addition or removal of substances and factors which decrease soil productivity, quality of plants and groundwater. So these are mainly caused when chemicals are added into the soil in the form of pesticides, herbicides and fertilizers for increasing productivity. So these chemicals reached in human beings through food chain and causes harmful effects. So now causes of soil pollution are the number one is the pesticides, which are actually synthetic toxic chemicals with ecological repercussions. They are used in killing pathogen, pest, and inhibiting unwanted growth in agriculture, horticulture, forestry, and water. Now we know that organochlorines, they are very persistent insecticides and which show biological magnification. Example, DDT, BHC, aldrin, endrine, diendrine, etc. These these insecticides, they are not soluble in water and non-biodegradable also, hence get transferred from lower level in higher level in food chain. So pollutants get 10 times concentrated at each trophic level. Now carbamates and organophosphates, these are less persistent and more biodegradable and are nerve toxins. So they infect the nerves. Insects also become resistant to certain pesticides after successive use. Nowadays we can see that mosquito repellent, you are using it and mosquito is not going away from your home. So after again certain days when new mosquito comes, they are not habituated with that and of course they die. So some mosquitoes dies. Nowadays we use herbicides in place of pesticides. So herbicides are generally metabolic inhibitors. Example, sodium chlorate, sodium arsenate and many others. They decompose in few months and not very much persistent. So arsenic containing herbicides are harmful to mammals. Some herbicides cause birth defect too. And nowadays the pesticides industry has used its attention to herbicides such as the herbicides nowadays that is used in pesticides industries, the sodium chloride NaClO3 and the sodium arsenate, they're used nowadays. Now most of the herbicides, these are toxic to mammals, but they're not as persistent as organochlorides. These chemicals decompose in a few months. Some herbicides even causes birth defects. So herbicides are more prone to insect attack and plant disease than fields that are weeded manually. So, but about the total population, total circle of the population, only a certain angle, only a little amount is caused by these pesticides and the herbicides. A large number of other compounds that are used regularly in big industries, in factories, and in manufacturing other plastic industries also. So they causes large amount of population, pollution. So So nowadays, what happens due to these fertilizers, that organic fertilizers are engaged instead of using these chemical fertilizers, uh, and it involves organic pesticides, biofertilizers, and disease-resistant varieties. Now we have studied about this environmental pollution. You have to know that World Environment Day is on 5th June. Our Earth Day is on 22nd April, and Ozone Day is on 16th September. These things you must know. Among the industrial waste, they may be both solid and the liquid. It may be both solid waste or the liquid waste. They may be biodegradable or non-biodegradable. They may be biodegradable or non-biodegradable waste. Now, biodegradable waste that included the generated or includes waste from the cotton mill or food processing units, paper mills, and textile factories. And non-biodegradable pollutants or the industrial waste, the gypsum from fertilizer industries. Fertilizers industries produce a lot of gypsum. Mud and tailing from metal industries. The metal industries produce a lot of mud and tailing. Okay, from these are mud and tailings from metal industries. Uh, Slag from steel industries, of course, slag from steel industries, and fly ash from thermal power plants, etc. Fly ash and slag from steel industries also, and fly ash from thermal power plants. So these are all this industrial waste. And these quantities of this toxic waste, they are usually destroyed by uh, controlled incineration. Uh, where small quantities are often burned, along with factory garbage in open bins. Uh, Now you have to know certain things, that fuel obtained from plastic has high octane rating. it contains no lead, and hence it is known as the green fuel. So what is the green fuel? That is fuel contained from the plastic waste. It is from the plastic waste. Now this recent trend in development nowadays, recycled plastic cotton are used in chemical and textile industries. So clothes will be made now in the global textile market. Now recent trend is that generating power from this rotting garbage. So in India there is a good news that where there is a lot of power cut, we'll be able to get a lot of power from this rotting garbage, which causes a lot of pollution. And so a pilot plant or project is under process, uh, and different types of biogas will be produced, and there is the mainly methane gas. Is this mainly the methane gas which will be used in in this field.